Good morning or good afternoon, Mr. Smith. My name is Gabriel Barton, and today I'm going to be doing my presentation on the chemistry of aerospace engineering. Give me one moment just to pull up my script, and then time the time being. Blah 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 blah. Here it is. Okay. Have you ever wondered how planes and rockets fly? What makes them fly, how they kind of came to be in a way? Well, good news for you. This video is going to be all about the chemistry of aerospace engineering. Now, the story of planes began right around the time of 1899 when the Wright brothers first started to work on their original plane. Here's a little picture of the first plane made by the Wright brothers. It's really blurry, but you can see it's kind of got something going on here, like semblance of an actual modern day plane. See, the first structural material used in the aircraft, or in the powered aircraft, was wood. The main frame of the first plane was flown by the Wright brothers. Excuse me. It was made with timber covered with fabric. Now you see, this doesn't have to do much with chemistry, but it does have to do a lot with physics. They needed something that was kind of light but durable, and because timber is wood, wood has air in it. It's kind of like how a bird has air in its bones, hollow bones. It can fly easier. The fabric was just, I guess, to be soft. I'm not really sure why they chose fabric. But the wood was chosen in the early aircraft because it was good to its strength to weight ratio. The beginnings of flight. Reiteration, the engineering of the first plane began around the time of December 1899 with the Wright brothers. There's some blueprints of the first plane. You can't really see too much of it, but it definitely goes into a lot of detail. I've read this. So the physics of it all is that they kind of invented a very, very premature version of a combustion tube. There was no combustion. It was actually kind of powered by fans. I'll go in more into detail later. Now, that little hang glider is almost nothing compared to the beauty of modern day aircrafts. Ah, excuse me, sorry. Had to, sorry for, I don't know, I had to sneeze almost. But the beauty of modern day aircrafts is outstanding. Modern day engineers are involved primarily in designing the aircraft and the propulsion systems, the studying of the aerodynamic performance of the aircraft, and construction materials. Now, the construction materials can vary, but most planes are made out of, you know, metal, but a special type of metal. And the performance of the aircraft kind of relies on the combustion chamber, how that works. I'll show more of that later, because that's kind of how planes fly. That's where all the chemistry is involved. However, the designing of the aircraft is solely based on how many, like for commercial airliners, it's how many passengers can be fit in, and for jets, it's how fast you can go, just depending on the aircraft exactly. But most of it is designed purely for flight and for the physics of the plane to allow flight. All aspects of aircraft science and technology are areas of expertise for the aircraft engineers. They conduct research, design, and development work on the parts and machinery that the aircraft use to operate. Utilizing software and computer-aided design, they combine technical know-how with software skills to exhibit models. As an aircraft engineer, you would assemble, test, and modify engines and other support equipment for a variety of plane types. Now, according to Google, the top most six impressive feats of aerospace engineers are: number one, the invention of flight, flying. Number two, the first person in space, space. the Apollo program, the Voyager probes, reusable rockets, and the solar impulse. Now, most airplanes today are made out of aluminum. I know I get made fun of for saying it like that. Aluminum is a strong yet lightweight metal. The Ford Trimotor, the first passenger airplane from 1928, was made out of aluminum. The modern Boeing 747 is an aluminum airplane as well. Other metals such as steel and titanium are sometimes used to build aircrafts. These metals are also used for their strength to weight ratio, like the wood in the very beginning of the plane's history. Now, how the plane works. Any airplane needs to have a propulsion system to provide thrust in order for the plane to actually fly through the air. The Wright brothers' internal combustion or piston engines, as well as contemporary jet and rocket engines, all rely on the burning to generate the power that shoots the plane into the air itself. Now, combustion is a rapid chemical combustion of a combination of a substance with oxygen, involving the production of heat and light. Think of combustion as a lot of miniature explosions constantly happening one after the other over and over and over again. Now, here we have two diagrams of combustion chambers. Now here we have the propeller, which sucks in the air. You have the propeller gearbox that turns the propeller. Here's the inlet where the air actually comes into it. The compressor compresses the air like crazy into super dense pockets of oxygen. Once the oxygen is super dense, it goes into the combustion chamber. The combustion chamber gets sparked, and all of that air, as you know, fire loves oxygen. It basically eats it, needs it to survive. So, what happens when you feed something a lot of what it eats? It gets bigger, right? It gets stronger, faster. This is basically how it works with combustion. Once you feed the fire all that super condensed air, it explodes into these insane kind of explosions. They're really small. Well, they're not small. They're powerful, but they're dense. Now, those dense explosions go into the core turbine, and from here they go into the power turbine, causing the plane to, fly through the air. This is what powers the actual plane itself. This is more like a cold section, hot section diagram. Air inlet, compression, combustion, exhaust. Now the exhaust is what actually shoots the plane into the air. In the chemical process of combustion, an object quickly combines with oxygen to produce heat. The chemical that is reacting is referred to as the fuel, and the oxygen supply is referred to as the oxidizer. The fuel might either be a gas, liquid, or solid, and the liquid hydrocarbon such as gasoline is frequently used as fuel for airplane propulsion. Similarly, the oxidizer may be a solid, liquid, or a gas. Sorry, I think I'm coming down with something. In the process of combustion, fresh chemical compounds are created from the fuel and the oxidizer. Exhaust is the name for these materials. The majority of exhaust is produced by the chemical reactions between the fuel and the oxygen. The exhaust from the combustion of a hydrocarbon-based fuel, such as gasoline, that contains both water and hydrogen, water plus hydrogen, and carbon dioxide, which contains carbon plus oxygen. Now, the oxidizer used in aircraft propulsion is air, a gas for combustion to take place for combustion to take place in an aviation engine, we must operate the fuel because the oxidizer is a gas and the fuel is a liquid. The evaporation and mixing of the fuel and air occur in the carburetor of the engine. The combustion itself occurs in the combustion chamber. Other elements that were present during the combustion may also be present in a chemical combination in the exhaust, nitrous oxidus, NOx, nitrogen plus oxygen, can also be produced when gasoline is burnt in the air, which has a 21% oxygen content and a 78% nitrogen content. Due to the high temperature from the heat emitted, the exhaust is typically in the form of a gas. However, some exhaust can develop as liquid or even solid, for instance, a soot, a type of solid exhaust produced by several combustion processes. That is all for my presentation. I hope you enjoyed.